All right, we're going to go ahead and start, and we will let them in as they arrive. What we're looking at in this section is rational functions, and so they're fractions. And we're given a graph, and it asks us some things about it. The first question here is, what is the equation of the horizontal asymptote? Asymptotes are lines that don't really appear on the graph, and we show them with dotted lines, and it's what the graph goes toward as you go to infinity. So as you get larger and larger values, it approaches this line, and this one is the horizontal, and this is the vertical. And for the equations on the first part, I think that's all they want you to know is what these are. So the first question asks us, what is the equation of the horizontal asymptote? Well, on this one, it is the x-axis, and the equation for this would be y equals 0. So problem 1, I'm just going to call it the horizontal asymptote, and it is y equals 0. So there we go. The next one asks for the vertical asymptote, which is this one, and this will be x equals something, and this is x equals 5. So vertical asymptote, x equals 5. And they ask us to find the domain. It's a little hard on these with the screen because we need the picture to do those. I'll write down what we're supposed to do. Find the domain and the range. And what you have to watch out for is that it doesn't actually touch this point. So domain, you're coming from negative infinity, it's going to go up to 5, but it's not going to touch it. So you're going to do negative infinity to 5. Make sure you use parentheses, and then you'll start again at 5 with the other part of the picture, and it will go to infinity. For range, it'll be the same way. It's coming from negative infinity, and it's going up to 0, but it's not going to touch. So negative infinity to 0, use parentheses, union, and then we'll start up again at 0 for the other part of the picture, and it will go to infinity. So we'll just check those with the key rather than typing it. And there you go. You've got parentheses with the union, and this one parentheses with the union, and we're throwing out the 0. Stop me if you have any questions as we go. All right. Number 2 is a similar question. It's just a different type of picture. It's still a rational function. So this is our function up here. And they want to know the asymptotes again. So your horizontal asymptote is this one. And so that is going to be y equals 4. Your vertical asymptote will be this one, and that will be x equals 2. Let's see what else they asked. Check those. So y equals 4, x equals 2, domain and range. So your domain here, it's going from negative infinity up to this asymptote, but it's not going to touch, which is 2. Use parentheses, and then do union, start up again at 2. That's the other piece of the picture, and it will go to infinity. For range, the lowest point on these pictures is a 4. So we're going to start at 4, but we're not touching, and it will go to infinity. So here we go with parentheses. It's 2 that we're throwing out, and this one starts at 4 with a parentheses because you're not touching and goes to infinity. Hi, Charlie. How you doing today? Glad you could join us. All right. Problem 3. Says find the domain of the given function, and we have done domain before, and the places you watch out for are denominators and radicals. And in this section, what we really have to watch is denominators. So denominators cannot be 0. And so this question, and I'll write it so we have it in notes. They want us to use set builder and tell the domain. Set builder is actually nice for these. It's less writing. And all you care about here is that denominator. 12 minus x cannot be 0. And then solve. So subtract your 12 from both sides. So negative x is not equal to negative 12. Divide by negative 1. So x cannot be equal to this. 2 negatives will give you positive. So we're throwing away the 12. So with the set builder, all you have to enter is the 12 here. It already has it set up for you. So it will be the set of all x such that x is not equal to 12. And then they want us to give the interval notation. Well, it'll be like those other two we did. You're coming from negative infinity. You're going to 12, use parentheses because you're not going to touch it, and then start again at 12 and go to infinity. Four is the same kind, asking about the domain. So it is the denominator. We have to make sure it's not equal to 0, except this one is a quadratic, so we'll have to factor. And remember, it's your exponent that tells you whether it's linear or quadratic. And so we want to set this equal to 0 and solve, and then throw those values away. So this is a trinomial, goes into 2 sets of parentheses, like signs both minus, and you're multiplying to get 28, adding with like signs to get 11, so 7 and 4 will work. So we want to make sure this is not equal to 0. So we set each one equal to 0 and solve. All right, so add 7. So we're going to throw away 7, and this one, we're going to add a 4. So we're going to throw away 4. So for their set builder notation, what they started with, the set of all x such that x is not equal to 4 and 7. So that's a much nicer way to write it, actually, for these, less work, right? They do want the interval notation. You want to go in order left to right, so smallest to largest. So we're coming from negative infinity to 4 with parentheses, start up again at 4 to 7, parentheses, and start again at 7 to infinity. Any questions there? All right, question 5 is similar. I left it in just because the factoring is a little more work, so we can just remember how to factor those. Right, and so the question again is domain. That's all they're asking on these. And so we want to know when is this 0, and we will throw that away. Pause for just 1 second. Mouse. Right, so we're going to set this equal to 0 and solve, and then throw those away. So if you factor with trial and error, you're going to have 2 sets of parentheses. This says do different signs. And your choice on this side is 6 and 1 or 3 and 2. And on the other side, you have 1 and 4, 4 and 1, or 2 and 2. And I'm going to try the 3 and 2. And then over here, you just have to try them to see what works. If I do 1 and 4, this one's not going to work. Your check is outside and inside, so minus 12x plus 2x. That is not giving me 5, so this one doesn't work. So I'm going to switch that 4 and 1. This stays the same. The 4 here and the 1 here. So this is minus 3x plus 8x. That gives me 5x, and that is what I want. Right? Don't get so caught up in that you forget what you're supposed to be doing. Now you want to see when is this 0. So when is 3x plus 4 0? And when is 2x minus 1 0? So you're going to subtract your 4. These are 2 steps. And divide by 3. So negative 4/3 is a bad value. Add your 1. So 2x equals 1. Divide by 2. So a half is a bad value. So we're going to throw those away. So for the set builder, set of all x such that x is not equal to negative 4/3 and 1/2. That will be our first answer. And then I'm going to see if I can just get a little bit more space. For interval notation, and we want that negative 4/3 first because that's the order, smallest to largest. So we're going from negative infinity to negative 4/3, use parentheses, start again at negative 4/3 to 1/2 with parentheses, start up again at 1/2 to infinity, and that throws out the negative 4/3 and the half. Any questions there? All right. Next we have, I'm going to go to question 7. Six, you just have to do it for both fractions. See when either one would be 0 and throw those away. Right. 7 starts the same way, right? Gives us a rational function, r of x, equals 4 over 36 minus x squared. And so we're going to solve. This is a difference of squares, this denominator, and we're doing domain again. So we want to know, when is the denominator 0, because that's bad. You can do difference of squares, or you can solve it with the square root method. Doesn't matter. So we have 6 plus x and 6 minus x if you're factoring. And then just solve each of those. So if 6 plus x equals 0, then we need to subtract the 6 from both sides. So it will be negative 6, that's bad. For this one, subtract your 6 and divide by negative 1. So x equals, this will actually be a positive 6. So we're going to throw both of those away. So the set of all x, oh, they didn't ask us for that way this time, did they? I'll just put it since I started. Cannot be negative 6 and 6. And so we're going from negative infinity to negative 6. Start again at negative 6. Those parentheses are what excludes it. Up to 6. Start again at 6 to infinity. And the other problem, and I'll have to do a new screen. I wanted it all together, but it's not going to fit. So same kind of question. And remember, when we start with domain, we start with a set of real numbers and then throw out things. And so if we try to solve this denominator, when is this denominator equal to 0? We can't do a difference of squares because this is plus. It has to be minus to do difference of squares. And so we can solve with the square root method. So we'll subtract a 1 and take your square root. So it will be x equals plus or minus square root of negative 1. But remember, this is an I. So this is a complex number. And we weren't even starting with complex numbers. We're starting with the real numbers because you can't see complex numbers on the rectangular coordinate system. So for this one, there's nothing that you're going to throw away. So you've checked this, but these doesn't give you any values to throw away. So this one will be negative infinity to infinity. Let's see. For Ryan's question, the denominator has a plus instead of a minus. This problem, Ryan, or a different problem? This one. If you have the plus, you're not able to factor it. So if it's two terms with a plus, you aren't able to factor it. It's not difference of squares. And if you try something else, you would have to cancel out a middle term. The only way is with different signs. So it would not factor. You would have to go with the square root method with the plus. Anything else there? All right. Next I went to question 8. And so when they start having you give the equation from the problem instead of from the picture of your vertical asymptotes, they come from the domain. And what happens when you go to graphs, the graph blows up. So that's why it goes to these asymptotes when you hit that bad value. So like when this one, and I'll pull it on the calculator in a minute and show you, at 14. 14 is the bad value there. It's going to make that denominator 0. And so that's where the graph is going to blow up. So to find your vertical asymptotes, and let me write the problem so we'll have it in the notes. We still are looking at domain. So when is this 0? And it is 0 at x equals 14. This is actually, you would throw it away if they're asking you domain, but if they're asking you for the vertical asymptote, that's the answer. So vertical asymptote is x equals 14, and you need the x equals with it, right? So if we're answering domain, so really you do the same work for this, for domain and for vertical asymptote. Just watch what they're asking you. If they're asking domain, you have to throw this away. If they're asking vertical asymptote, this is your answer. So there we go. We'll talk about holes a little bit more in another problem. If you can factor this rational expression and something cancels out off the denominator, so if I had an x minus 14 up here and they canceled off, then it would make a hole at that value instead of an asymptote. So this one does not have anything that will cancel, and so this one does not have a hole. So we would say does not exist. It'll be clearer when we get one that has a hole, but if the denominator will cancel when you've got it all factored, so if I had an x minus 14 on top, then it would cancel out, and that will leave a hole instead of an asymptote. So since this did not factor and have anything cancel, it doesn't have a hole. But I'll come back to that when we get one that does. And I did pick one on purpose that does. So let's see, number 9. Oh, I was going to show you this one on the calculator. Let me pull it up a second. Yeah, I'll have to change the window. Sorry. So y equals, and when you enter these in your calculator, you have to be really careful. You want parentheses around the numerator and parentheses around the whole denominator, because the calculator will do order of operations, and it says multiplication and division are equal. So if you hit this divide, it's going to divide by just the first piece. So that's why you have to use parentheses on these, on both the numerator and denominator. So I have 14x, close the parentheses, divided by parentheses x minus 14, close parentheses. All right, let's look at the graph, and I'll have to change the window because we said 14 is where the vertical asymptote is, and that is going to be where this blows up. So let's change the window. So we'll just change all of these to 20. So we want a negative 20, positive 20, and we'll change the scale to 2. Negative 20, positive 20, and 2. And I really needed some more over here, huh? This was not such a good example. This is your x equals 14, and this is where the graph blows up. I'll find another one to show you a better picture that doesn't need a different window. Okay. We'll put the window back to normal. So zoom standard gets it back to normal. Sorry about that. I should have left that one off. All right, so let's see. Question 9. And so we're asked for the vertical asymptotes, and we're asked about holes again. So you want to factor your denominator. Now this one is not a difference of squares because you have x in both of those. So you're going to do GCF here. You're going to take an x out, and that will leave x minus 16. So you have two values here that would be issues, a 0 and a 16 if you're looking at domain. If you're doing vertical asymptotes, if one didn't cancel, you would have two vertical asymptotes. But when we write this problem in factored form, this x will cancel. So whatever this would be equal to, when we set it equal to 0, is going to give us a whole because it canceled out. So this would be x equals 0, and this would be x equals 16. Add your 16 to both sides. This one gives you a whole at x equals 0. This one gives you a vertical asymptote at x equals 16. And it's because the x canceled. So that's how you determine a whole. So our vertical asymptote is just x equals 16, and the whole is at 0. And this one you don't have to write the x equal to because it's not an equation for it. It's just a value. And this one's not real good to show you on the calculator because it's going to go off the window. So we'll leave it. Switch back to blue. All right, same kind of question. This one is also going to have a hole. So the question is asking about vertical asymptotes or holes. And so what you care about is the denominator. When is it 0? So you have to factor it. This is a difference of squares. It has minus in there. So it factors to x plus 6, x minus 6. And then you would set this equal to 0 and solve just the denominator. But this one has a piece that cancels. And so this one that cancels gives you a whole instead. So x minus 6 equals 0. Add your 6 to both sides. This one gives you a whole instead of an asymptote. This one, set it equal to 0. Move your 6, so subtract 6 from both sides. This one gives you a vertical asymptote. It did not cancel. Any question there? Right. 11. And hopefully you looked in your packet let's see if I have a packet here and I can tell you what page to make sure you refer to. There is a table. What we're going to look at now is a horizontal asymptote, and you do it from a table, and it in your packet of notes, it is on the top of 85. So top of 85, you have 3 situations, and it's determined by your degrees of your numerator and denominator. Remember, degree will be the highest exponent, and these might not be in descending order, so don't necessarily just pick the first term. So this one, I'll write it like it is, but this one is not in descending order. Right, and it is asking about the horizontal asymptote. And you need to just memorize that table. So it has to do with degrees, and you want to know the degree of the numerator. So it is the highest exponent. I'm not going to rewrite these because in all these problems they're long. So your degree is the highest exponent. So it's going to be 4 on the numerator, 1 on the denominator, right? And your formula or your table says if the degree of the numerator, just call it m, is, I'll put the whole table for this one. If it's less than the degree of the denominator, then your horizontal asymptote is y equals 0. But that's not the case here. The degree of the numerator is bigger, right? The second case, the degree of the numerator equals the degree of the denominator. Then you take a fraction of the leading coefficients. So I'll just put L's there. And this case is the last one I'm going to put here. Your degree of your numerator is greater than the degree of the denominator because it's 4 over 1. So this one does not exist. So this is your rule for this particular problem. So you're going to find it from that table. So this one you would choose the other one. Right? And we'll do one of each one. Except I'm not going to rewrite that table every time. So 12. These will be faster for you to do than they are for me because you don't really have to write it. All you care about is degree. Your degree on your numerator is 1. Your degree on your denominator is the highest exponent is a 4. So your degree on your numerator here is less than the degree of the denominator. And so this one, the equation is y equals 0. And also I have 13. So they try to make them look really mean, but this is, when it asks about the horizontal asymptote, it's actually a very easy question. Right, so all we care about is degree of the numerator. So you have a 3, and degree of the denominator, 3. So this time they're equal. And when you have that case, you're going to use the leading coefficients. So it will be of that term with the degree. I just didn't rewrite these in descending order. That's way too much work. So it will be y equals -2 over -4. And then you have to reduce and clean that up. Your two negatives will make a positive, and 2 over 4 will give you 1/2. So y equals 1/2. Whoops. Whoops. Come on, Miss H. I don't know what I did different last time. So that is how you find the horizontal asymptote. Go back to your table. So vertical asymptote, it's all about the denominator. See what you have to throw out, and that gives your vertical asymptote, unless one cancels. Horizontal asymptote, you're getting it from that table. All right, question 14. And we want to pick which graph this is. So I will bring the calculator back on this one. And we'll clear that out. And we'll clear out this piece. Let me make sure my window, it did go back to standard. Okay. So when I put this function in, I have to use parentheses. So I have 1, and then divided by x minus 4, close parentheses, and then your plus 2. And we'll say graph. Right, and the calculator does not put the horizontal asymptotes on there. You can kind of see where it's happening. It's happening right here. It does put the vertical asymptotes. So this is not really a piece of your graph. That's the line they go up toward. This is where this one is blowing up, and it's blowing up at a 4 because that would make the denominator 0. So this vertical asymptote is at x equals 4. That is how the graph behaves there. It goes away from that because it knows denominator can't be 0. And so you can match this up. This is you're picking out the right answer. I would use my calculator for this one. And I hope you guys all have a graphing calculator, because you really need it on these sections. You can use Desmos.com, but the part with the table, that piece will be hard. And there might be a way to get the table off from there, but I haven't played with it. All right, so you do have to watch and make sure these are not flipped. These are not flipped, so ours is moved. Notice it's moved over from the 0, 0. These are just transformations to this. The standard function is 1 over x. And so this one is moved to the right 4, and it's moved up 2. So we can look at these. right? This one's moved over to the right 4, and it is up 2. I think it's going to be choice A. Choice B, they flipped them, right? Notice this is the one going this way instead of here. So it's not that one. This one has moved to the left instead of the right. And when you do the transformations, remember, horizontal goes the opposite way. Okay, so that's why this one, it's minus, so it'll go to the right. Okay, and this one has moved down. It went to the right, but it's moved down. So choice A is going to be our choice, and I'll just go ahead and enter that. I can move our calculator over so we can see it. So this was 14, and there's nothing really for me to write. I could write, so if somebody looks at it, this was the problem we did. On the calculator. Let's submit it, and it's good. And before I do another one, I want to pull up the standard graph, which is 1 over x. And if you just have 1 over x, you don't have to use the parentheses because you only have one piece in the numerator and one piece in the denominator. And this one is going to blow up at 0 itself. So this is your standard one, and then the transformations will be done to it. So let's look at 15, right? And so these are variations or transformations of the standard one, and then you're going to match these to graphs below. You can certainly use your calculator for each one. You won't need to really. We can compare it to this one and see how these make us move. Right, so let me just write it on here. And we're matching these. I'm not going to write every one. If anybody wants it, they can watch the video. And let's pull our calculator back up so we can see it as we go. All right, so I'm not going to enter this. You could enter this exact one. All right, and I'm going to match it below. So let's compare to this and see what happens, right? So we've got a +3 with the x. Remember, that'll go the opposite way, and that's horizontal. So this is going to shift to the left 3. And your +4 at the end is going to make it go up 4, right? So this standard one, it's going to shift left 3 and up 4. So when we look in the choices, we look at this one, and this one has shifted to the right, right? We want to shift to the left, so it's not going to be this first choice. Okay, this one has shifted 5 units to the left. We wanted 3, so that one's not going to be it. And it looks like I must have skipped one. I skipped B, that's okay. This one has shifted 3 units to the left and 4 units up. So this one is going to be choice D. I think I will write these. So we can just talk about what each piece does. This one has an extra piece in it. Right, it has this negative in the front, which is going to make it flip. Right, so this is a vertical flip. This will make it move left 5, up 2. And that's a variation from our standard graph. So we're going to flip it upside down. So this one's going to turn this way, and this one's going to turn this way. So in the other quadrants, instead of where they are. And we're going to go 5 left and 2 up. So A is flipped, but it has moved to the right, not to the left. So let's see. B has flipped, and it is moved to the left. 5 units. Here's your vertical asymptote. It's not marking it, but you can see those ones the graph goes close to. It is moved up 2. So B is going to be your choice on this one. Let's see if I can fit those on the same screen. All right, third one. This one, there's no flip, so it's going to shift left 4 and down 3, but no flip. So left 4 and down 3 looks to me like C. Moved left to 4, negative 4 is your vertical asymptote. You are down 3, negative 3 is the horizontal asymptote. So C is your choice on this one. And there was only one more. So by process of elimination, it should be A. We will see if that is true. This one flips, so it's going to be in the other quadrants. And it is flipped. It's going this way and this way instead of the other way. Okay, so that takes care of your vertical flip. This one is going to move to the right 5 and down 4. All right. It has moved to the right 5 and it is down 4. So this will be choice A. And you enter these just on the side here. So the first one we said is D. This one we said is B, C, and this one was A. So you guys doing okay with that? All right, so I think we're okay with time. So we'll go ahead to 16. And this one I won't be able to write. Because I would have to draw the picture to be able to write it. Okay, so using our reciprocal function, and that's what you call the standard 1 over x. We're going to do the variations, but this time we have to give the equations of it. So it's kind of the opposite thought process from the last one. The last one, they gave us the equations and we picked the picture. And we'll just put our calculator back up. And that's the 1 over x. So it would look that way with 1 over x. So this one, and first of all, this one is flipped, okay? You are up going this way instead of down. So we're going to have a negative. And I guess we have to type the f of x. I'll write it first. So f of x equals negative, because of the flip, it has moved over to the right 5 units, right? And that would be a minus, because it goes the opposite. And it has moved down 2 units. Your horizontal asymptote there is -2. So that should be our function here. And I think you probably have to enter that f of x. There we go. And it did have the negative in the front. So make sure you don't miss out on that. The next one we have, now this one is turned the right way, like our calculator, right? And so it's not going to have a negative in the front. It has moved over to the right 3 spaces. There's your vertical asymptote. So this will be 1 over x minus 3. It has moved down 1. So 1 over x minus 3 and down 1. This one is flipped again because you're going, your curved part goes the other way. So we'll have a negative in front. And it has moved to the left 4 units, because here's your vertical asymptote. If you're unsure if it's 4 or 5, look and see which would be the vertical asymptote. So -4 is the vertical asymptote. So this would be 1 over, and we said this one has flipped. So we need a negative in front. 1 over x plus 4 would make it move to the left. And this one has moved up. 5 is your horizontal asymptote, so it's moved up 5 units. So a plus 5 at the end. So we're good there. And this one. So we're back to the right direction, so no negative in front, so no flip. It has moved to the left. This one has moved 3. So -3 is your vertical asymptote. It's moved to the left, so it will be x plus 3. It has moved down. -4 is your horizontal asymptote, so it's moved down 4 spaces, so a -4. There you go. Right, and 16, that was 16. 17 is going to be similar, but it is a different standard one. So we'll try to get in a couple more questions. Right, so this one, and I'll do the standard one first on your calculator. You're comparing to 1 over x squared. So we'll change our input, and so we'll do our 1 divided by, and this will be x to the second. And so this is a symmetric graph. And so the standard one looks like this. So if it's turned the other way, then you have a flip. So it looks like the second one has a flip. Okay. And your horizontal asymptote is y equals 0. Vertical asymptote is x equals 0. So that is our standard one, and we'll try to make the equations. So this one is the right direction. Okay, it's not flipped. It has moved to the left 3 spaces. So this is going to be 1 over x plus 3. That's inside. And it's moved up 1 space because 1 is now your horizontal asymptote. So your x plus 3 is inside the parentheses and your square is right beside that. The next one has flipped upside down. So it is going to have negative at the front. And I should have said f of x equals. So we have flipped upside down. All right, and this is where your asymptote you look for. It has moved up 4. That will be the end. It has moved to the right 2. So it's going to be 1 over x minus 2 squared. That would make it move to the right. And it has moved up 4. So there's your negative, which makes it flip. 1 over x minus 2 squared plus 4. This next one, there is no flip. So no negative in front. It has moved to the right 4, and it has moved down 5. So to the right 4 would be minus 4 inside with the x, and it's moved down 5. That would be out here. And one more. This one has flipped upside down. I'm going to put it over here. Okay, so upside down is going to make it a negative. Right? It has moved to the left only 1 unit because here's your asymptote. Right? 1 unit to the left, but that is going to be an x plus 1 inside the parentheses. And it has moved down 1 unit because now your horizontal asymptote is y equals negative 1. So it has moved down 1. Sorry, I was trying to get that so you could see the whole thing. There you go. So that was 17. Okay. And then they start having you analyze the graph. This is one section where this is very different from my notes in my video under the chapter video, because there I'm teaching it and teaching you how to draw it. Here, I suppose there is no drawing tool, and so you're having to analyze their graphs instead of draw it yourself. It is a good idea to make sure you can draw it yourself. All right, so we'll get a new screen here and write down what we need to. All right, so they want us to analyze this graph. And we are going to say all the pieces that you would need to graph it yourself. And don't forget you have a graphing calculator too. All right, so these are the things they're going to have us do. Find the domain, which will also give us the vertical asymptotes. And so for domain, we care about when is the denominator 0. So set this equal to 0 and solve. You could factor here. This is a linear equation though, so it's not really going to matter. Let's subtract the 8 and divide by negative 2. So we get x equals a positive 4. For domain, we're throwing that away. So And they didn't say how we had to write it. So for domain, x cannot be 4. So we'll say it's negative infinity to 4. Start again at 4 to infinity. Okay. Vertical asymptote you find the same way, except you're keeping this. You're not throwing it away. So vertical asymptote is x equals 4. Nothing would cancel. You cannot cancel this x off with this one because this whole thing is not a product. If x had been in every term, then we could. Okay. So we'll make sure these are right. Actually, we'll go ahead and just work on the list, and then we can check right or wrong. Okay, this one does not have any holes. So for the next piece, no holes. Horizontal asymptote. This is back to your formula. And it is all about the degrees of the numerator and denominator. Your degree of the numerator is 1. Your degree of the denominator is 1, so they are the same. So you're going to work with the coefficients of those, and it will be y equals negative 5 over negative 2. 5 over 2 doesn't reduce, but you do have to clean up the signs. So this is going to be y equals positive 5/2. That will be your horizontal asymptote, and we can check these answers. So there is my domain. This one, x equals 4. That is my vertical asymptote. There are no holes, so we're good there. The equation with horizontal asymptote, it will be y equals 5/2. Now they want the x-intercepts and the y-intercepts, and then a table. Okay, go back up to the problem. So we need to remember how to find those. X-intercepts, you plug 0 into y. Let's do y-intercepts first. So y-intercepts, plug 0 into x. So it's negative 5 times 0 over 8 minus 2 times 0. Well, this gives us 0 on the numerator, and 8 minus 2 times 0 is 0. So this is 0 over 8, which is 0. So the y-intercept is 0, 0. For the x-intercept, and I'm going to rewrite this so I have it all together. This is a little different. You don't have to do as much work as we normally do with an x-intercept. Right, x-intercept says set y equal to 0. This side is y. So 0 equals this whole fraction, but all you really care about here is the numerator, because if you think of numbers, if you get 0 over anything, it's going to be 0. So you can actually not worry about this and just do 0 equals negative 5x and solve, because it doesn't matter what this is if you get a 0 on the numerator. So you divide by negative 5, but you get x equals 0. So the x and y intercept are the same. They are both 0, 0. And then they want us to do a table of values. There's your intercepts. They let us choose anything we want to put in there. If you were drawing this yourself, you would put these pieces that you have on the grid. I would put the asymptotes on first with dotted lines, and then put your intercepts, and you would pick points in each section. but we're not going to draw it ourselves by hand. So and they want us to have 4 points. And so we are going to go strictly with the calculator for these. And they don't want you to use the ones you already have used, the intercepts. They don't want you to use those. So we'll do y equals, clear this out. Remember parentheses for your numerator and denominator. So negative 5x, close, divided by parentheses 8 minus 2x, close, graph. All right, there's your picture. So you'll be able to match up, but you still have to fill out that table in the problem. All right, so I'm going to do second table. And this error, this is where the graph doesn't exist. That's the bad value that we throw away. So I'm allowed to pick anything I want. So I'm going to pick 4 points. And let's see if I can make that stay on if I move it over here. Right. And I'm going to try not to pick these that keep going on and on because those are repeating and the answer might not like those. All right. I'm not going to pick that one because I know that's a repeater. I'm going to pick 2 and negative 2.5. So your answers can be different here. 3 and negative 7.5. I can pick 6 and 7.5. And just going to show you, you can move the cursor and see other values. All right, so we'll use negative 1 and 0.5. But you can have different answers in this part. So you're just going to pick them, and I would pick them straight off that graphing calculator. I would not plug in. The arithmetic is not nice. If you plug in, so like if we plugged in negative 1, I mean, this is the steps you would have to go through, so don't really do this. So negative 5 times negative 1, 8 minus 2 times negative 1. And so this gives us 5 over 8 plus 2, which is 10, which is a half. That is the same as 0.5, but that's only for 1 point. So if you're doing it by hand, I mean, that's what you have to do with each one. You know, then you would plug in a different value. And you would choose values. I want to pull the graph back up. Right? So if you're doing it by hand, you would choose, and I'm missing my horizontal asymptote here because it doesn't put it on. Anyway, it's about right here. So you would want something, it splits your graph into sections. You would want something over here. And then once you get a point or two, that's all you really need because the graph goes toward the asymptotes. Right? So if you get a point or two, so you know whether it's up or whether it's down, it will go toward the asymptotes as you go out. All right. And I think I used up all your time. I'm not going to enter, well, I can enter answers. We'll finish this one. Okay. I can enter those I picked. So 2 and negative 2.5. 3 and I was getting confused with my, because I have some overlap in my screens. 6 and 7.5. And it wouldn't matter if you entered that one as a fraction. On the calculator, there is not a button to show you the y-intercepts. The x-intercepts, you can do it, but it's easier to find it than it is to find it on the calculator, because you have to do the, I can show you in a minute. Let's finish this one. We have to pick the picture, and let's just pull the calculator back up. This one is in the wrong quadrant, so it's not going to be it. This one is also in the wrong quadrants. This one is in the right quadrants, but it is slid down this way. So it's going to have to be this last choice. This is the one that matches ours. It's going to mark me wrong on a bunch of stuff because I didn't answer them all. But it should have the graph right. So back to your question, Ryan. You can find an x-intercept on here. So you do a second calc, and it would be 0. So it would be 2. And it will be the point where the graph crosses. This one, actually, it's popping right up there and showing you the values. But if it doesn't pop right up and show you the values, you have to pick a left bound, a right bound, and then you guess. So you go through the 3-step thing. It's easier to do it algebraically because you're just plugging in 0. It makes the math easy. But not an easy way to find there's not a calculator way to find the y-intercept. All right, we'll stop there. How did I get that chart for the x-intercepts? I got the chart for different points. You have to put in points, and to get the chart on your calculator, it's second and graph. You're really doing table. So second graph, and there you go. So it's second table. That's your chart, and you can move the chart up and down. So these are to get your different points. Now, you could, from the table, pick off your x and y intercepts because you know the definition. X-intercept says put 0 in y. This one is the x-intercept, and y-intercept says put 0 in x. So this actually is your answer on that. So you can pick that from the table. Anything else? Yeah, make sure you can pull up that table on your, so it's second, and then it's the graph button, but you're really doing table above it. All right, so I will stop there.